we started off with motion in a plane. So concepts we were covering. So we have covered concepts pertaining to vector dot product, and vector cross product is what we were about to see. So dot product of vectors, we have seen the formulas for vector dot product in 2 dimensions as well as 3 dimensions. So now we are eventually moving on to vector cross product. How to evaluate vector cross product is what we are going to see. So the basic formulas and the method of doing it is also we are going to cover on that. So let me just start annotating. So I hope my screen is visible. I have already started sharing long ago.
Yeah,
then reconfirming.
It is visible. It is visible.
It is visible.
Yeah.
Okay. Now we are moving on with the next part, continuation of the topic that we were seeing about vector dot product, and then now we are moving on to vector cross product. So we'll see the basic formula pertaining to vector cross product. So if I'm having two vectors, say vector A cross vector B, okay, so let me put it that way, two unlike vectors, so A bar cross B bar, where I can express A in terms of its component, one of the vectors. So where A can be written as AX I cap, where I is nothing but the unit normal vector along X direction, plus AY J cap. Again, it's the unit normal vector along Y direction, and so on and so forth. So 3-dimensional system, I would express another vector as well. So I'm going to write that as AZ K cap. So I express like this. Similarly, we also have vector B being expressed in 3-dimensional coordinate system along with its components as bxi plus byj plus bzk. So wherein each one of them are represented by its unit normal vectors I, j and k cap respectively. So we are showing it like this. Now we are going to see how to use the cross product. So the cross product formula, A bar cross B bar, can be written as determinant format, wherein I am first writing down the unit normal vectors in their directions. As per Cartesian coordinate system, we have I, we have J, and we have K. So I'm first writing them, and then I'm writing down the corresponding components. As you can see, I cap component, J cap component, and the K cap component for first vector A. So you can see the component of I cap is AX, so I'm writing AX. The component corresponding to J cap is AY, and component corresponding to K cap is AZ. Similarly for B, I'm going to repeat the same in order: BX, BY, and BZ. So once I have specified, now we are going to apply the determinant rule, which comes in mathematics, determinants. So by using sign convention, very important. So the sign convention is also necessary for us here. So I would put alternating positive and negative signs. Okay, so positive for I, negative for J, positive for K. So I'm expressing it. So now let's apply the determinant rule. So when you apply the determinant rule, so what you do, you're going to block the corresponding row and column pertaining to I. So corresponding row and column of I needs to be blocked. So I'm going to do that. So I block it, and you can see inside you have a 2 cross 2 matrix which is left. Okay, so you do a cross multiplication. So which can be written as, first you cross multiply downwards, which is AY times BZ. Don't forget to write the corresponding terms also in order. That's also quite necessary. So you can see that it is I cap for the first one, open the bracket, AY times BZ, minus, as you go upwards you will have to take negative sign. Okay, so minus BY times AZ. So I am done with the first terms. So we are done with the first corresponding column and row operation. Now I'm going to remove that blocked lines that I have drawn. So I've removed it. The same way we repeat for J cap. So the center one, the corresponding row and the corresponding column. So I'm going to block. Okay. So the sign is minus obviously. So minus J cap. Open the brackets. You can see I'm left with again a 2 cross 2 matrix. So AX BZ as you go downwards and you multiply. One second, let me just reduce the width. Yeah. So AX BZ. As you go upwards, you put a subtraction sign. That is, you subtract minus DXAZ. Simple as this. So we are done with this corresponding 2 cross 2 matrix. And finally, you block the last row and corresponding column of K. And again, you're left with a 2 cross 2. So it's going to be plus K cap times. So again, we can write AX BY minus DXAY. That's it. Close the bracket. So this is how you write, the cross product of two vectors as far as three-dimensional Cartesian coordinate system is concerned when you have vectors, the unit normal vector I cap, j cap, and k cap respectively. So this is how we do. This method is called as the matrix determinant method. So we would be using this directly to solve questions pertaining to cross product. Okay, so this is one important rule. Okay. So now we are moving on. So this is the basic idea that you need to be knowing. So we are done with the matrix method. So now we will move on to the general method of doing it. So if I'm going to have two vectors, say vector A cross vector B, in general, if I'm going to find out the cross product, then the formula would be vector A times vector B into sine theta. So AB sine theta. Now it's very important to note that this A and B are nothing but the magnitudes of vector A and vector B. Now, how do I write down the magnitude? So again, vector A can be written as square root of ax square. So I'll put it that way. Plus ay square plus az square. Okay, so this is how you calculate the magnitude. Just this under root square of individual terms. The individual component terms, when you take square and you add them under root, you get the magnitude. As simple as that. Same way for B, magnitude of B would be under root dx squared plus by squared plus dz squared. This is for a three-dimensional vector. Vectors need not be three-dimensional each and every time. You may also have two-dimensional vectors. That's also quite possible. So it's completely based on the nature of the vector being specified. All right. So this is all about the cross product of vectors, wherein theta is the angle between those two vectors, vector A and vector B. So the angle between them is theta. So again, the sine angle of that to be multiplied. Simple. So this is all about it, the cross product. So without any further delay, let's move on to the next part. The major part, which is projectile motion. The next topic in this chapter, we will be seeing that. So what is meant by projectile motion? Okay. So how can we visualize projectile motion? Even before I give you the concepts, the basic formulas. So I'll just show you a small animation video so that it is you will have a visualization of projectile motion. So let's look at the video. I'm just getting it loaded. Just hang on. So I'll just share that also. Yeah, I hope I'm audible, right? You guys are able to hear me? Yeah, I think there was an audio disruption. I didn't notice that. Okay, I hope I'm audible right now. Fine. So I'm just sharing, a video on projectile motion. So we are going to the next part, for projectile motion. So I'm sharing an animation video. Just hang on. Yeah, that's, loading.
To talk about mo. Good day, learners. This is Easy Engineering. Concept of a straight line motion. The movement. The cannonball along a straight path to a straight line motion. Projectile motion mentions projectile.
Yeah. So I'm sharing the screen for projectile motion. Just let me know if you're able to see it. I'm sharing the audio as well. So yeah, I think it started sharing. I hope you guys are able to see it. Let me play.
Projectile motion. In previous video, we learned the concept of a straight. But now how about if an object experiences moving along horizontally at the same time vertically? This kind of motion is called projectile motion. In this video, we will learn the concept of a projectile motion. Suppose you are firing a cannon at some angle. The cannonball will follow a parabolic path during its flight before it reaches the ground. We will try to understand the movement of the cannonball. First is its velocity. Initially, the cannonball has initial velocity. This initial velocity can be resolved into its x direction as and y direction as. This means that the cannonball is moving upward while moving to the right. When the cannonball moves upward, the velocity in x direction is constant or the same as the value of, while the velocity along y direction is approaching to 0. When the velocity along y direction is equal to 0, the cannonball is in its maximum height from the ground. The cannonball continues its parabolic path. During its flight, the cannonball experiences a motion going downward while going to the right. This time the velocity along x direction is still constant, but the velocity along y direction is approaching to the value same as the initial velocity along y direction, but in negative value to indicate that it is going downward until the ball reaches the ground and the velocity is 0. To sum up everything, the velocity along x direction is constant and the velocity along y direction is changing with respect to its position. Initially, the velocity along y direction is when the cannonball reaches the maximum height, the velocity along y direction becomes 0, and the velocity of a cannonball before it reaches the ground is equal to the initial velocity along y direction, but in negative value. This time,
Yeah. So this animation video gives us an idea of a projectile motion. You can see the motion taken by a cannonball. You can see it's not moving straight. It is taking a curved path. This is basically a parabolic path that you're seeing. So this, type of motion or this trajectory is, called as projectile motion. So it is having, an initial velocity because when the cannon is being shot, you can see that metallic ball or the cannon is taking a parabolic path, and it is changing its trajectory. As you can see, it moves up, and as it reaches the maximum height at Vy is equal to 0, you can see that it is going to go for a decline. It's going for an incline, and then it's going for a decline. So there are two different paths which can be observed or interpreted from this corresponding curve that you're seeing here. So which where there is an incline curve, and then you can see that there is a decline curve. So that is what we observe here. Now, why do you think it's again coming back? Why can't it move up forever? Now, that's quite not possible because,
Due to gravitation.
yeah,
Due to gravitations.
exactly, due to gravity. Earth's gravity, is going to definitely pull it downwards. If there weren't gravity, then it's a different story. But because if you're doing everything on the surface of the Earth, so obviously the frame of reference is going to be the Earth, and Earth's gravity is going to play an important role. So it's going to pull, the object with a gravitational, force, preferably of, the value of g, which is 9.86 to be more accurate, meters per second square. It's going to pull it downwards. Okay, so that's the reason it's going to come down, and again, final velocity is going to be 0. That's the reason, because it's going to stop, come to rest, or it's going to be stationary after some time t. So that is what we are observing. Okay. So you can see that there are two components for the object that is moving along this curved path. There is an x component, and you can see that there is a y component as well. So it is having two components. There is variation also. As the object is going to move, there is variation along y and x axis simultaneously. That's what we can observe from the animation video. Okay. So now we have different aspects, as we have now seen the basic directions in which it is moving. That is, it's first moving upwards and then trying to come downwards. So let me first finish the entire video, and then we'll look at a simulation, where things would be even more clear to you guys. And then we'll go back to the notes. Okay, let me just resume the video. Let me pause myself.
And the velocity of a cannonball before it reaches the ground is equal to the initial velocity along y direction, but in negative value. This time, let us look at the acceleration. There is no other acceleration governing to this kind of motion, but only the acceleration due to gravity, which is equal to 9.8 meters per second squared. This acceleration is pointing downward and is constant during the cannonball's flight. Lastly, for distances, there are only two distances which we should give attention. These are the maximum height, when the cannonball's velocity along y direction is 0, and the distance traveled of the cannonball during its flight. Before we end, let me leave you with this trivia. Did you know that in projectile motion, to have a maximum distance travel of an object, it should be fired at 45-degree angle? That is all for now. I hope you learned something today. Once again, this is Easy Engineering.
Okay, so we are done with that video. So let me go back to the simulation, which I've got it ready. So I'll stop sharing and reshare it. Yeah. So I am now moving to the simulation window. Now you can see this is a simulation from PHET, Colorado. So where we have the different topics. So now I have selected projectile motion. Now you can see that there is a cannon which is already pre-installed in the simulation video. You can find that. And we have various parameters based on which, we can try to study what's happening. All right. Now you can see at the bottom we have a setting for initial speed. It is by default set in 15 meters per second, as you can see at the bottom left corner. Okay. So that's quite available. I can also increase if I want. You can see if I increase, it keeps changing, and if I can also decrease. Okay, so for now, let's keep it as 15 meters per second, just as an example. Now you can see the cannon is placed not at the ground level. It is placed at a certain height. Okay, you can see there is, a pedestal or a cylindrical block on which it is being placed. And you can see the angle of projection is 30 degrees, right? Can you see that? With respect to the horizontal plane, it's making an angle of 30 degrees. That's what you can see. Now I can even change that also if I want. Like I can reduce it even to 0. I can increase it to 20, 30. It goes on like this. So first we'll see, how it is moving. What if I'm going to, place it at say 0 degrees? Okay. So I'm keep placing it at 0 degrees and then I'm trying to, shoot a cannon. So let's see what's going to happen. In that case, I'm going to fire it. Okay. So at the normal speed, I'm going to show it. So you can see on the top, we can even select whatever you want. So say cannonball. So I have chosen cannonball. Air resistance for now, I'm not considering. So say when there is no air resistance, what is going to happen? Then let me shoot it. So I hope you can see this is the trajectory. Once I have shot, you can see the blue colored path has been retraced. Okay, and you can see that is the trajectory or that is the path taken by the projectile. Okay, so that is the path. Now I'm going to increase the angle. Say, let me increase it by 30 degrees. And let me again shoot it with the same initial speed or initial velocity of 15 meters per second. Yes, now you can see it went quite far away also. Okay. What I'm going to do, I'm having a tape that is available. So let me take the tape and I want to measure what is the maximum height. Okay. So what is the maximum height? And we can also measure it. Even if I place it also, I can find out what is the maximum height of this corresponding projectile also. You can see as it is trying to move away. So here height is 12.78 meters. I'm placing it here. It's 12.86, 12.87. Here it's 12.85. So this is the maximum height. Okay. The height for 30 degrees maximum is basically 12.87. It is showing as per, the data that we have. Now what I'm doing, I'm again increasing it by 45 degrees. Let me again shoot it. Third one. Now you can see again the maximum height is attained here at this point. Okay, which is 15.73. Let me check leftwards. 15.7. Okay, and 15.73. Okay, so that's the maximum height. Yeah. So 15.73. That's for 45 degrees. So the maximum height in the sense, the height that it is reached, once it's going to just start to decline. Okay, at that point where the velocity components it becomes 0. Okay, then it starts going downwards. Okay, so you can see it is 15.73 for 45. Now let me again increase to 60 degrees and you see what's happening then. Okay, so correspondingly, you can see there are different trajectories that I'm getting. Okay, so appropriately, so you can see here, it is moving. So where and all it is landed also, you can see when it is placed from a certain height. The same thing, if I'm going to now reduce this to 0, and if I'm again going to perform it, now the results would be totally different from what we have, interpreted. Okay, so I'll keep it at 45 now, and let me again shoot it. Okay, so at 45 degrees, this is the curve that I'm getting. At 60 degrees, let me shoot. You can see this is the curve that I'm getting. Okay, now and at 30 degrees, let me again shoot it. This is for 30 degrees. Okay, so like this, you can see that for varying angles, we can see what is the result. Okay, yeah. So you can see for 45 degrees, whatever curve that I have got, there is a maximum, horizontal range that has been obtained from the corresponding data. So you can also, try to measure using this tape. I can pull this and also I can measure what is the corresponding range. But anyways, if I'm going to place it here, the sensor itself is giving me the details. So we can find out. So where you can see the corresponding maximum horizontal range is obtained. So based on this, we can easily find out. Now this is basically a simulation for us to understand based on varying angles of projection of how the trajectory can be. So that is the idea. And look at the time also. It takes, it's 1.8 seconds. Here it takes 0.7 seconds for 30, okay, 45. So appropriately, 60 and so on and so forth. So that's what we try to understand from this. And also the velocity components also we can try to find out. If I'm going to check these boxes. Okay. So there's a basic idea for us, to understand, how a projectile motion works. Okay, and what is the horizontal range and where it can be maximum. So all this we try to understand from this corresponding simulation. Okay, so this is just for visualizing. It gives us an idea to visualize. And again, you can here give the inputs and you can try to study what are the outputs also. Okay, so now let's go back to the blackboard. So I'm sharing the blackboard now again. So now things would be even clear to you. Yeah, I've started sharing the blackboard again. So coming back to the projectile motion part. So we'll see it. So once we have seen the simulation, now things would be at ease. So when an object is being projected from the ground level, so we'll try to study. And then we'll see after being projected from a certain height. There are different cases to this. So let's analyze each and every case. Okay. So let me draw the x and y axis first. So say this is your y axis and this is the x axis. So I am drawing the axis. Now with respect to the axis, when an object is being projected, say it is moving, it is taking a parabolic path. This is the parabolic path. Okay. And it is also being projected with some initial velocity u. So I'm showing that also. So this is the initial velocity u. That is the velocity with which the object is being projected from the ground level. And the angle that it makes, let us take with the horizontal, the angle it makes is theta. So this is theta. Okay. And so let me mark different points. Let me mark this maximum height. So this height is h, the maximum height that it is attaining during its course of motion. Okay. And the horizontal distance that it is going to cover is called as range. Okay, horizontal range. It's given by the letter r. Now these are certain things that you will have to know. Now I'm going to resolve the vector, initial velocity vector u, in both horizontal and vertical components. Now what is the vertical component? That is u, y, and what is the horizontal component? ux. Okay. Since it's making an angle theta with the x-axis, so ux would be u cos theta. What about uy? It would be u cos of 90 minus theta. You know that cos of 90 minus theta is going to be sine, right? Because this is 90 minus theta. Okay, so that comes from trigonometry. So that becomes u sine theta. Simple. So these are the vertical and horizontal components of the projectile. Okay, so I've written both the components. And the distance that it is going to cover along the x-axis, the distance traveled is equal to speed into time. So it is nothing but ux into t. So we can write this as, so ux is, we have already found out, u cos theta. So let me substitute. It becomes u cos theta into t. That is the distance that is going to travel around x-axis. The same way distance it would travel along the y-axis can also be written as y is equal to uy into t, because distance traveled is equal to speed into time. Okay, so you can express it. But here you can see along y-axis, so as it is going to move in the the corresponding parabolic path, now there are two different aspects to this. It's not just u sine theta into t. You can see that gravity is also doing its job, and there is variation along the vertical direction. Hence, it is uy into t minus half gt squared. So when I substitute the values, I get u sine theta into t minus half gt square. Okay, this comes from the second equation of motion, very important, since s is equal to ut plus half at square. You may be wondering how did this equation came? It came from the second equation of motion. Why did we take negative sign? Because it's going against gravity as it's going to move upwards. Okay, and hence the negative sign. So this is very important. This is for y-axis direction. Okay, simple. Now, what about this second equation? What equation does it represent? So when you try to look at this equation is of the form y is equal to ax minus bx square. So according to maths, if you're going to compare this equation, you can see this equation represents the equation of a parabola. Okay, so this represents the equation of a parabola. Simple. That's the reason it's obviously it's taking a parabolic path, and hence there is no doubt that this expression is going to represent a parabolic path. Okay, simple. So again, velocity of the projectile at any time t can also be written. So let me write that. So velocity of, say, the projectile at any time instant t can be expressed as v is equal to under root of vx squared plus vy squared. Okay, so I can express that. Let me substitute the values. So vx squared can be written as u cos theta the whole squared plus u sine theta minus gt the whole squared. So we can express it like this. So when you go for a simplification, you get root of u squared plus g squared t square minus 2 g tu sine theta. So we can express it like this when you go for a simplification. Okay. So this is one important aspect that you need to keep in mind. Same way, this velocity component makes, say, if it's going to make an angle of, say, let me say, if it makes an angle of beta with the horizontal plane, then how can we express it? Then we can express using the tan ratio, opposite upon adjacent. So we can say tan beta is equal to Vy upon Vx, variation of y upon x-axis. Okay, let me just write it again. So Vy upon Vx. So we can express it like this. Simple. So again, substitute the corresponding values. This is u sine theta minus gt upon u cos theta. So these are important formulas which you need to keep in mind, because each and every time it's difficult to derive all of them. So this is again necessary. Okay. So again we move on. The horizontal range of the projectile is given by the letter r. You can see the horizontal distance that it is covered. Okay, from point O.
Mani Sundaresan has got some question, I think. Yes, Sundaresan?
Yeah, you can ask.
மைக் ஆன் பண்ணி பேசுங்க சுந்தரேசன். அது நீங்க ஹேண்ட் ரைஸ் பண்ண அவங்களுக்கு தெரியாது அவருக்கு.
You can ask because yeah.
Yes, sir. Yes. Sir, u sin minus gt போட்டுக்கீங்களா சார்? அங்கே சார் half gt இல்ல?
Yes. இது வந்து நான் velocity component எழுதியிருக்கேன். Displacementக்கு வந்து I have not written. நான் மேலே எழுதின y வந்து is for the displacement. That comes from the second equation of motion. இங்க u க்கு எழுதியிருக்கிறது வந்து it is for velocity, not for displacement. ஓகேங்களா? That's the reason that's got this formula. Okay, so நீங்க யாருக்கு எந்த டவுட்டா இருந்தாலும் please you can definitely unmute yourself and ask. ஏன்னா because I'm presenting, I'm using a tab, so இதுல வந்து I'm not able to see if you raise the hand. That's the problem. So you guys can feel free, please don't hesitate. We are here to help you. So you can definitely, unmute yourself and stop me at any point where you feel, there is a doubt or something. So don't hesitate. All right. Fine. So I hope that's clear, right, Sundaresan?
Yes, sir.
Okay. So இப்போ horizontal range க்கு போலாம். Let's look at what is horizontal range. That is nothing but the horizontal distance that your projectile is going to cover. You can see I've already specified there. Okay, OP is nothing but your horizontal range. It's marked as R, capital R in red, as you can see. So I'm moving on to that. So how the expression for horizontal range is being written. So we look at that. That's given by the formula R is equal to U squared sine 2 theta upon G. So this is the relation for horizontal range. Okay, so we'll be using this formula to find out horizontal range. So again, this is necessary for us. Let me box it. And then we have the maximum horizontal range. We'll be looking at the conditions for horizontal range. Okay, so there is one special condition which is very important. I think you guys all know how sine theta works, right? So that sine value is maximum for theta being pi by 2 radians, or say 90 degrees. Sine 0 is 0, whereas sine 90 is 1. So therefore it's maximum for sine 90. So what value of theta, if you're going to input here in this formula, would you get sine 90? Yeah,
45.
45, exactly. So now theta 45 porton, obviously 2 times 45 would give you 90, and you will get maximum value. So our max or maximum horizontal range is possible for 45 degrees, and I'm substituting that you get sine U square sine 90, because theta 45, 2 times 45 is 90 upon G, sine 90 being 1, you would get U square upon G. So that is the maximum horizontal range formula. Okay. Another kapram, we have something called as time of ascent. What do you mean by time of ascent? Okay, the time taken by the projectile to reach the maximum height is called time of ascent. அது அந்த parabola the inclined part மேல போறதுக்கு to reach the maximum height is called time of ascent. Okay, same way that would also be equal to time of descent. That is to come down from the maximum height to the ground. That is to the horizontal plane again. So that is time of descent. Ascent is to go up, descent is to come down. So this is equal to U sine theta upon G, where U is your initial velocity of projection, theta is your obviously the angle of projection, G being acceleration due to gravity. Okay, so this is called time of ascent and time of descent. Both of them are equal. So மேல போறதுக்கு எவ்வளவு டைம் எடுக்குதோ அதே டைம் தான் அந்த மேக்ஸிமம் ஹைட்ல இருந்து கீழே வரதுக்கும் it's going to take. Okay, yeah. So the next part is time of flight. So what is time of flight? Okay, we can call this TF, time of flight. So time of flight is the total time taken by the projectile, to when it is just being projected and the time it's going to reach the ground. So don't you think time of flight should be time of ascent plus time of descent? Isn't it? So ரெண்டுமே நம்ம add பண்ணோம் அப்படின்னா you would get time of flight. So what would be the answer for this?
2u sin theta by g.
Yes, it's going to be 2u sin theta upon g. You just need to add u sin theta plus u sin theta. That would give you the time of flight as this. Okay, so here on the top, let me write it, time of ascent and time of descent formula. So let me box it. So that's also quite important. And then we have written the expression for time of flight. Okay. Next, maximum height reached by the projectile. So we'll see that also. So maximum height pakla. So that's given by h. So h is equal to u square sine square theta upon 2g. So this is the expression for maximum height reached by the projectile. Okay. So this again you need to keep in mind. So for maximum height reached by the projectile, again the theta value you can input it the same way we did it for range. Okay, you can put the value of theta. And one more important relation, whenever we are giving competitive exams, there are certain relations and important tips and tricks. So one of them is the horizontal range relation with maximum height. So the relation is tan theta is equal to 4 upon n. So this relation is very important for us, where the range is n times the maximum height. Okay, so this is one relation that we can use actively to solve questions. So that formula, a small trick. Okay, so that is one aspect. Yeah, and then we also have expressions for kinetic energy. Kinetic energy வந்து எல்லாருக்கும் தெரிஞ்ச ஒரு relation தான். So the kinetic energy of the projectile at a corresponding point, at a point of projection. So I will give you that also. Kinetic energy of the projectile at maximum. Okay, instead of maximum, let me first tell at the point of projection. Then we'll see maximum relation. Okay. So that's given by KE is equal to, formula for kinetic energy everybody knows, half mv squared. So here we will not write mv squared, instead we will write mu squared, because it's initial velocity component, half mu squared. Okay, so this is the basic formula. At maximum height, again what we do, so the kinetic energy formula is going to get modified as, so first I'll give you the writing part. So kinetic energy of the projectile at maximum height, say at maximum height h, is given by kh, keh in particular for maximum height, that's half mu squared cos squared theta. Okay, so this is the formula that you need to effectively use for maximum height condition. So like this we have relations which are very important for us. அதே மாதிரி நமக்கு angular momentum relation கூட இருக்கு. We also have angular momentum relation. So let me write that. Say angular momentum when projectile is at maximum height h. So then also you have a relation. Angular momentum, the symbol is L. Okay, so let me write it as LH, suffix H. Okay, so you know that angular momentum is given by mvr. So that is the general formula. In this context, we are going to slightly modify this. The mass would be as m only. V is nothing but your velocity. So u cos theta into maximum height instead of r, maximum height h. So mu cos theta into h. Okay, so that is what we get. So I'm going to substitute the values. I will get mu cos theta. Maximum height formula, just now we wrote it as u square sine square theta upon 2g. So this is the complete formula for angular momentum at a height h. So like this you can get the relation. Okay, so like this you have important formulas that are very useful for us. Okay, and then the important relations we're going to see. Say when horizontal range is maximum, being maximum, then maximum height is being related as h is equal to, okay, u squared. You know that it is for sine square theta 45 degrees we take, already I told you. So u square sine square 45 upon 2g, that would be equal to 1 by 4 times u square upon g, which is r max upon 4. So these are the relations that we have when you go to substitute. Okay, so like this we have the corresponding relations. So these are the relations pertaining to maximum height and maximum horizontal range relation. That's why h is equal to r max upon 4. Okay, so that's how we got that relation. And momentum also we have relations. Let me write the relation for momentum. So
sir,
yes, solunga.
sir, before 2 points, sir.
Yes, before 2 points, Cherry. Kinetic energy point.
Sir, the projectile at H max இருக்குல்ல sir, அதுல ஏன் சார் u squared cos squared theta யூஸ் பண்றீங்க? ஹைட்ன்றது வெர்டிகல் தானே சார்? அப்ப சைன் தானே சார் யூஸ் பண்ணணும்?
Okay, எந்த ஃபார்முலா சொல்றீங்க? It is for kinetic energy or maximum height சொல்றீங்களா?
Kinetic energy, sir.
Kinetic energy. Okay, the first one is on the top. இல்ல second one.
Half m u squared cos squared theta, sir.
Okay, half mu squared cos square theta. Fine. So இங்க பாத்தீங்கன்னா kinetic energy of the projectile at maximum height. That's what you're asking, right?
Yes, sir.
Okay. So here what we are writing, why we are taking cos component is, see, when an object has been projected, you can see that there is variation along both x and y. Okay, but here as it is reaching that maximum height, anga what is happening to the component? The vertical, see, there are two components, no doubt. Vertical component வந்து அங்க வந்து இருக்காதே, that becomes zero இல்ல, because of gravity at that point it becomes zero. That's the reason we don't take. Only the cos component would cease to exist. The vertical component becomes zero at that instant of time of maximum height. அதனால we only take u cos theta but not sin theta. Okay,
Yes, sir.
yeah,
Understood.
அதனால அது வராது. Yeah, okay. Say, now moving on to the next part. So we are looking at linear momentum relation. So linear momentum of the projectile, say at a point of projection, general point away எடுத்துக்கலாம். இது வந்து நம்ம எல்லாருக்குமே தெரிஞ்ச ஒரு ஃபார்முலா தான் momentum. So right from grade 9 எல்லாரும் படிச்சிட்டு தான் இருக்கோம். So linear momentum formula is given by P is equal to m into v, product velocity v ன்னு சொல்லுவோம். ஆனா இங்க u அப்படின்னு சொல்லி நம்ம அதை மாத்திக்குவோம். ஏன்னா there is initial velocity. Okay, so symbol for initial velocity is being u அப்படிங்கிறதுனால we put m into u. Simple. So this is the linear momentum of a projectile at any point of projection. So generally we can write this formula. So this is something which is quite common. I even need not specify, but still it's necessary. That's the reason I'm specifying it here. So these are all the important formulas for projectile motion where the projectile is present at the ground level. நம்ம பாயிண்ட் ஆஃப் ப்ரொஜெக்ஷனும் கிரவுண்ட் லெவல்ல இருந்து அது வந்து லேண்ட் ஆகிறது கிரவுண்ட் லெவல் கீழே இருந்துச்சு அப்படின்னா ஆப்வியஸ்லி இட்ஸ் கோயிங் டு லேண்ட் ஆன் த கிரவுண்ட், தெர் இஸ் நோ டவுட். ஸோ வென் ப்ரொஜெக்டைல் இஸ் அட் பாயிண்ட் ஆன் த கிரவுண்ட், no, it's not at a height, then all these formulas are applicable. But not necessarily all projectile motion questions have to be like this. You have different cases. So now we are going to the second case. This is quite vast. So இப்போ நம்ம அடுத்த கேஸ் போறோம். That is, if the projectile is projected at a height h, கீழே இல்லாம கிரவுண்ட் லெவல்ல இல்லாம ஒரு கிரவுண்ட்ல இருந்து ஒரு குறிப்பிட்ட ஹைட்ல ப்ரொஜெக்ட் பண்ணும்போது what is going to happen அப்படிங்கறத we are going to now analyze and see different formulas pertaining to that. Okay, so let's look at the next case, case 2 for projectile motion. So we look at that. This is a projectile projected horizontally projected horizontally from a height h. Say from a height h with velocity u. So ஒரு ஹைட்ல இருந்து நம்ம அதை ப்ரொஜெக்ட் பண்றோம். Assume this is the ground level. இது கிரவுண்ட் லெவலா இருக்கட்டும். இப்போ இதுக்கு மேல I am having a certain height. I am placing a block of height h. So இதோட height வந்து h. ஓகேங்களா? Of height h. Now the object is projected from this height h. அப்போ என்ன ஆகும்? When I'm projecting it from this height h, so it has been projected with u velocity u. Okay, and then it is going to fall like this. It's going to take a path like this and it is going to eventually land like this. So like in the mari we are going to assume. Then what is going to happen? Appo what is the horizontal range அப்படினு பாத்தீங்க அப்படினா, so this would be the horizontal range of the projectile. ஓகேங்களா? இப்போ இங்க maximum height பாத்தீங்கன்னா அது height h தான். ஏனா from that point only I am projecting. ஓகேங்களா? So obviously நம்ம இது maximum height அப்படின்னு சொல்லி claim பண்ண முடியாது. You can't say this is maximum height because already from a certain height only you are projecting it, and with an initial velocity component, and you can see it is projected like this. Not to mention that it is projected with certain angle. No, so here I am not having any particular theta with respect to this corresponding object. One second, I think I erased by mistake. Let me just redraw it. So this was the corresponding part. Yeah, it is projected like this, children. Okay, from this point. So with respect to the horizontal on the theta on the kadayad, there is no theta here. Okay, that is how it is being projected. So when it is being projected like this, as it is going to fall downwards, you can write down the components also. So what is a component of Vx? If you see, it's again the component is going to be u. Say this angle can be beta. We can assume. Okay. So this is Vx component and this is Vy component, which is g into t. So like this you have two different components. So now we will see the formulas pertaining to this as it has been projected. So vertical component of velocity pathina of the projectile at any time t is g into t, and its acceleration due to gravity times t. Okay. Gravity when that acceleration is velocity upon time. So by rearranging it, you will get this formula. It's not a big deal. Now,
minus தானே சார் வரணும், minus gt.
But it is moving not against gravity, it is moving towards gravity. Against போட்டீங்க அப்படின்னா நீங்க minus சொல்றது is absolutely right. Okay, for against. Here it is falling towards gravity. So அதனால sign convention வந்து பாசிட்டிவா தான் இருக்கும். Okay. Yeah. So இப்போ நம்ம velocity of the projectile at any time t பார்க்கலாம். General formulaவே பார்த்துடலாம். So we'll see from there. So velocity of the projectile at any time t, at any time instant t, என்ன அப்படின்னு பார்த்தீங்கன்னா, so v is equal to அதே மாதிரி under root of vx squared plus vy squared. Again vectors வந்து we try to find out what is the resultant of these two vectors. So angle வந்து 90 இருக்கிறதுனால under root of vx squared plus vy squared plus 2 vx அதெல்லாம் நீங்க simplify பண்ணீங்க அப்படின்னா உங்களுக்கு அல்டிமேட்டா இதுதான் கிடைக்கும். So you will get this. Let me substitute. Vx is nothing but u. So u squared plus vy is g into t. So g square into t square varum. Substitute பண்ணீங்க அப்படின்னா. Okay. Then again you can find out what is the direction also by using tan theta. இங்க வந்து நான் beta எடுத்திருக்கேன். So tan beta would be vy upon vx. Okay, which is gt upon u. So in the mari you will get the relation. So what will be the time taken by the projectile? In this case, you can also find out that. So time taken by projectile to reach the ground is given by the formula t is equal to under root of 2h upon g. So this is the formula which gives the time taken by the projectile to reach the ground, okay, from this height h. Okay, so this is the time. Adhe mari equation of this trajectory, okay, equation of this trajectory abdina, don't get confused. Trajectory is nothing but the path taken by the projectile. Okay, that's called trajectory. Okay, so equation of this trajectory is nothing but y is equal to g upon 2u squared into x squared. So this is the equation of trajectory. This is actually mathematical. Okay, this is just for your understanding. Nobody is going to test you on equation of trajectory. Just a basic idea. So velocity ஏற்கனவே நான் கொடுத்துட்டேன். So these are, the basic aspects that you will have to know. So the ones I'll box it here. So all these formulas are necessary for a projectile that is projected from a certain height h. Okay, so with that we'll move on. So projectile motion la நம்ம ரெண்டு கேஸ் பார்த்தாச்சு. ஒன்னு வந்து when it is projected from the ground level, one more when it is projected from certain height. So இது ரெண்டுமே வந்து நம்ம பார்த்துட்டோம். Now we are moving on to the last part of projectile motion. So last partல வந்து we have again the third case அப்படின்னு கூட நம்ம சொல்லலாம். So let me put it as case 3 of projectile. இது என்னவா இருக்கும் அப்படின்னு பார்த்தீங்கன்னா, when it is projected on the inclined plane. இப்போ inclined plane அப்படிங்கிறது வந்து அதுவே ஒரு கான்செப்ட் தான். So that is a separate area. What if it's going to be projected from an inclined plane? Okay, that is also quite possible. Yes. So we are going to now see what would be the differences if it has been projected from an inclined plane. So let me give the heading for this as projectile motion on an inclined plane. So that is what we are going to now see. Okay. So how the diagram is going to be going to look, or how can you try to visualize it? So we will look at that. So let me put an inclined plane first. Let me draw an inclined plane. So in force and laws of motion 11th standard we come across this. Some of the seniors would definitely be knowing, 12th graders. Okay, for 11th students it will be something new. Okay, so say இதுதான் inclined plane, ஒரு ramp அப்படின்னு கூட நீங்க வெச்சுக்கலாம். Okay, a slope, especially when you're moving up the slope. Okay, when it's going to make an angle of theta, you call this as angle of inclination. So இதுதான் நம்ம வந்து inclined plane அப்படின்னு சொல்லுவோம். Okay, I can also name the inclined plane as AB. You can see that the inclined plane AB is making an angle of inclination theta with the x-axis. So what if I'm going to place a projectile here? Now inga oru cannon vechittu if I'm going to shoot the cannonball, so how its path would look like? Okay, so it would again take a parabolic path like this and eventually end up somewhere there. Okay, so this is how it's going to look like. So then if I'm going to take this as theta, okay, and okay, let me specify the axis also. The initial velocity component is given by say u. Idha vandu na u nu eduthukuren. Okay, so then what would be this corresponding angle? If this is going to be theta, the inclined plane, and the angle between the angle of inclination and say your x-axis அது வந்து 90 இருக்கணும் அப்படின்னு வந்து there is no compulsion. Here we are trying to generalize. So this need not be 90, not necessarily. Okay. Yeah. So in that case, so I will take this as say இது தீட்டான்னு எடுத்துட்டேன். ஸோ இதை வந்து நான் ஆல்ஃபான்னு எடுத்துக்கிறேன். ஸோ let it make an angle of alpha with the horizontal. Okay. So I'm going to represent the axis also here. So vertical axis with respect to this. So vertical axis now வந்து இதை y axis எடுத்துக்கிறேன். Let me call this as x axis, x prime ன்னு எடுத்துக்கிறேன். ஏன்னா I took this completely horizontal as x. இது வந்து x prime, இது வந்து y prime வச்சுக்கலாம். Okay. So between x prime and y prime the angle is 90. No doubt about that. Okay. Now we can specify, the components of the projectile. Okay. So for that we have to know what is the angle made by the projectile with x prime. So what is this angle? How do we find out that angle? Anybody? கீழே வந்து theta கொடுத்திருக்கேன், alpha கொடுத்திருக்கேன். So can we find out this angle with x prime? Quite simple. If you subtract, you will get
90 minus alpha.
No, not 90 minus alpha. Not necessarily. இல்ல full முழு angle வந்து alpha ன்னு எடுத்திருக்கேன். அந்த சின்ன inclined ஓட angle வந்து theta. So don't you think this will be alpha minus theta? Right? Isn't it?
Yes, sir.
Yeah, it will be alpha minus theta. So what will be x prime or a component? U or a x prime component. That means ux வந்து எப்படி எழுதலாம்? ux prime. Ux prime can be written as u cos alpha minus theta. Same way, what will be u y prime component? It will be u cos of 90 minus theta, isn't it? Here, இது இங்க தான் u y prime component வருது. So u y prime component would be u cos of 90 minus theta. But my theta is alpha minus theta. So that complete angle. So I will directly write it as u sin of alpha minus theta. நீங்க அதை simplify பண்ணீங்கன்னா அதான் வரும். u sin of alpha minus theta is y prime. புரிஞ்சுதுங்களா? So this analogy is very, very important. Okay, I do understand it's quite complicated, but this is how you try to understand based on an inclined plane. Okay. So இப்போ வந்து இந்த ஒரு situationக்கு நம்ம each and every parameter we are going to see starting from range onwards. So what would be the range of projection? பார்க்கலாம். So we'll see range of projection on the inclined plane. So inclined plane la வந்து what would be the range? So அதுதான் பார்க்க போறோம். So R is given by the formula 2u squared sine of alpha minus theta, not theta minus alpha. Let me take it as write it there. Alpha minus theta into cos alpha upon g cos square theta. So this is the formula for the range of projection on the inclined plane. Okay. So this is how we are going to, this formula is what we are going to use on problems pertaining to projection happening or projectile motion happening on an inclined plane having an angle of inclination theta. So this formula is very, very important for us. So you can directly use it whenever you have situations where projection is happening on the inclined plane.
Can we close in 2 minutes, 2-3 minutes? Manish?
Yes.
Yeah.
Yes, uncle. Sure. Okay. Yeah. So the next part is we will see the formula for time of flight. So we look at that. So இங்க வந்து time of flight வந்து 2u sin theta by g அது கிடையாது. இங்க வந்து angle இருக்கும். So we will be writing that as 2u sin of alpha minus theta upon g cos theta. So this is the formula for time of flight. Adhe mari maximum range also you can write down for this situation. So let's see that also. The maximum range on the inclined plane So for that case, we will be getting R max is equal to u squared upon g times 1 plus sine alpha. Once again, sine, I think we have taken theta, yes. So it is theta. Okay, let me just modify it. Because it depends on, what parameter we have taken. So 1 plus sine theta. So this is the formula for the maximum range. Finally, when it is going to be maximum, again, based on this itself, you can find out. Okay. So the angle at which the range on the inclined plane becomes maximum, that also needs to be known. So the range on the inclined plane is maximum. So we can write this as theta is equal to pi by 4 plus theta by 2. So this is basically the condition that we will be using, for problems. Okay, so in the inclined plane, is a vast topic. So we have now covered in this session briefly all the cases of all the cases of projectile motion. First is complete projectile motion. Second is projectile motion from a certain height h. Third, projectile motion on the inclined plane. Okay, so these are all the different cases that we have seen briefly today in today's session, and we also looked at simulations, where you can visualize for yourself, and you can try to understand the concept. Okay, so we will solve questions. Now we have done with all the formulas, so then we can start solving a different variety of questions, which we will be doing in the next session. Okay, so I request all of you to go through the video, look at all the formulas, you can make a note of them. Okay, and then you can come back. So next week we'll start with the numericals, competitive questions.
Manish, I think I see in IIT JEE main papers many questions on this area. Am I correct?
Yes. Projectile
நிறைய
motion
questions இந்த ஏரியால தான் வருது. மெக்கானிக்ஸ் வருமா இல்ல? It's called mechanics.
மெக்கானிக்ஸ் கீழ we have this.
அதுதான் அதிகமான questions வர்ற ஒரு சாப்டர் இது.
ஏன்னா students, there are so many cases also where variety of questions can be framed.
Okay.
So அந்த vastness இருக்கிறதுனால, as you said,
நிறைய questions இதுல வருது.
probability of questions coming from this area is more.
Okay. Thank you.
Okay. Yeah. Bye bye children, take care.
Sir.